I'm excited now to introduce Mr. Craig Tiriak, Vice President of Product Management at Scale Computing. Craig, how you doing?
Hey, David. It's been a while. How are you doing?
Yes, sir. Doing good. It's good to chat with you again. Good to have you on. Take it away.
Well, I appreciate you having me on today. Really interesting topic, and I think you're going to see a lot of different interesting takes on what modern applications are and how to enable them, how to support them. I'm going to take a slightly different approach to this than I think you'll see from some of the other vendors, and talk specifically around how we enable modern applications at the edge of the network. And I'll talk a little bit about kind of how and why I'm focusing on that. But before I get into that, let me tell you about who we are as a company. So we were founded back in 2008, primarily focused on small and medium-sized businesses and providing unified storage for those companies. It was an interesting time. I've been with the company for about 11 years now, and I've seen this really through a handful of transitions. The first one was from that initial storage product to a modern HCI product. So this was in 2012 when we first launched our HC3 product, and we brought together servers, storage, virtualization into a really easy-to-use product. Again, focused primarily on small and medium-sized businesses. The most recent transition that I can think of as a company here that we've gone through, though, was back in 2017 when we had a multi-billion-dollar grocery retailer reach out to us and kind of talk through some of the issues they were having at running applications at the edge of their network. And this is before edge computing was really even a term, I would say. But as they started to describe the problems that they were facing, you could almost go down the list of features and functionality and kind of core tenets in the design of the product we had created for the SMB is to say that at any individual site, they had a lot of the same needs and requirements that an SMB did. And there are some obvious differences in that we'll probably cover as part of today's presentation. But that transition that's happened since 2017, where we have started to focus more and more on distributed enterprises in these edge computing environments, I think is, number one, really interesting, but also number two, very relevant to today's conversation, where we're talking about how we enable some of these newer, cooler technologies and running them specifically at the edge of the network. This is probably a quote you'll see throughout today's presentation from many presenters, but Gartner's predicting that by 2025, more than 85% of global organizations are going to be running containerized applications in production. And I think that's really driven based on some of the key benefits that we list here. And I'll just kind of talk through them quickly, because this is what we see when I'm talking to customers. I often hear them repeat this, but agile application development and deployment, containers just simplify so much of the developers' lives. There's a desire to rapidly and frequently deploy, and that's what containers are all about. Portability is another one that I commonly hear from developers, and that they want to have a unified experience across development, testing, staging, production, whether it's in the cloud or on premises, like we'll be talking about as part of this edge computing movement. Resource efficiency, another nice benefit. The smaller footprint containers allow for a much higher density, so you're increasing utilization. You've got the immutability of containers that really makes it highly repeatable to create and deploy these types of applications. And then finally, just the flexibility and choice. Kubernetes has really emerged, I would say, as the de facto standard for orchestrating containers. And you take that kind of API approach, the cross-platform consistency, combine that with the open source nature, and it provides just a lot of flexibility in deployment, either in bare metal or VM-based environments. Now, I've used the word edge computing, I don't know, probably 20 times in the last 2 minutes of talking here. So let me take a step back and define, when I say edge computing, this is what I mean. It really is any time you are running mission-critical applications outside of the four walls of the data center, and that could be a tier one data center that you host, or an MSP's data center, or it could be, cloud computing. Whatever that centralized piece is, it's something that's running on premises. And you can think of the edge as that physical location where things and people have to interact with the applications that you're deploying out there. And, there has to be something that runs on. Another Gartner quote that I'll cite here, which is, in the last year or so, it's said that around 10% of enterprise-generated data is created and processed outside of that traditional data center or cloud. And by 2022, the expectation is this is going to jump to closer to 75%. And that is a massive jump. And what's really driving that is this IoT movement, I would say, beyond anything else, and some of these more modern applications that we're talking about here today. Now we see at scale, we see 4 real reasons why people are moving toward this edge computing model or trying to retain an edge computing model in some cases. And it falls in these buckets. It's data explosion, resiliency, latency, and regulation. And I think we've got a poll after this that we can kind of see what sorts of trends we have out on the call today. But I'll quickly talk about these before we get into the poll. The first one is data explosion. You know, really with a lot of these modern applications where you're using machine learning, AI, video analytics, computer vision, in a manufacturing environment where you're inspecting things on an assembly line, or maybe it's a retail environment where you have self-checkout. Basically anything where you're doing on-premises data analysis that requires a whole lot of data or really low latency to be able to make quick real-time decisions based on that data, maybe including a GPU as part of that, or places where transient data exists, where it's the longer tail on that data, the less valuable it is to the company. So you want to be able to make that real-time decision and then maybe either delete the data or maybe only send the most important and pertinent things for modeling back to some kind of centralized cloud or data center. The other 2 that I have listed on here, resiliency and regulation, can sometimes go hand in hand. In fact, I was talking with a customer last week that is regulated by FEMA. It's a really interesting use case for requiring on-premises computing, but in their environment, they're required by federal law to, in the case of some form of a disaster, they need to be up and operational to serve the community around their retail site, which means that they need some level of, we listed here as resiliency, but you can almost think of it as autonomy of I need to be able to operate in the event that I do not have solid access to the internet. Another example of this is that same customer, further in the conversation mentioned that they had several remote sites that really the weakest part of their entire environment was that connection to the internet. And so in these remote sites where that's the case, you have to be able to run autonomously. So let me jump into the poll from here and just kind of ask the audience, based on those types of drivers that we see at scale computing for the need for edge computing, what of these, if any, and feel free to select all that apply, do you think really apply to your environment? I'll give it a second for these start to come in.
Yeah, we'll share the results from this poll here. I'm curious to see the responses. As Craig said, this is a select all that apply question, so you don't have to choose just one.
Yeah, I'll say, David, one of the things I often do when I'm on a call with a customer is the very first time I'm talking to them, I'll bring up this exact slide and I'll say, what's driving your need for edge computing? Because in today's modern application, modern design, it's cloud first for a lot of things. Anytime you can get away from having to manage that infrastructure, you should probably try to do that. But there are legacy applications that sometimes have to remain on premises, or some of these newer, cooler, whiz-bang features and functionality that people are working on have to be run close to the data that they're generating. And it's really interesting to hear those stories like that FEMA one that I just told you from the conversation last week that I had. Just really uncovers a lot of interesting use cases.
Absolutely, and I'm glad to see, I don't want to skew the results here, but I'm glad to see that there that there is a huge demand, really, for edge computing just based on these results that we're looking at. So let me go ahead and share those now.
Okay.
And it looks like 38% on my screen said data explosion, bandwidth restriction, 36% resilience and autonomy, 31% latency. Those are really the top 3. And so it looks like over 70% to 73% really have needs for edge computing out there. Craig, what do you think?
It's usually when I'm talking to a customer about this, there's like parts of every one of these that is their reason. So there probably is a lot of select all that happen in the results here, but not surprising to see them spread across all of them, to be honest. It's, we're talking data explosion and bandwidth restrictions. One of the applications that commonly comes to mind for me is video surveillance, where you're, having to make real-time decisions based on, the man with the red shirt's walking through the door at this second, what am I going to do? Or, dwell analysis in a retail environment, that type of thing, where you're having to make, very split-second decisions based on a whole lot of data, where you may, a video surveillance environment, maybe 5% of that data you'll ever have to go back to. But you want to keep that 5% if it's important. And so you need some level of ability to be able to say whether or not this is important, right? So some event has occurred. I need to mark that, and I only want to store this, long-term somewhere else. It's, just a lot of really interesting use cases. Appreciate everybody taking the time to fill that out. Well, kind of walking on from there, we've got, once you've decided that you need to run something on premises, and again, with 72% or more of you out there that are in this situation, hopefully you can relate to this. VMs are their thing. They're not going anywhere, but everybody's moving toward container-based or even Kubernetes-based deployments out there today. If you don't require orchestration and don't require multiple microservices working together, you probably get away with just running containers. And for those of you that are already running infrastructure on premises where you have to run VMs or even bare metal, going the container route is fairly simple. You just want to make use of that existing infrastructure. We see that really commonly when you are already running VMs. And I'll happy to spend some more time on this, but my belief is that VMs are not going anywhere anytime soon. If IT has taught me anything in my history with it, is that legacy things tend to stick around forever. I mean, look at tape drives. Right? I don't know how many years in a row I've heard for the call of tape drives being dead, and yet everybody still uses them in some way, shape, or form. I would expect the same is going to be the case for legacy virtualization solutions. The other thing I'll say on here is that basically once you've decided that the application that you're deploying does require some form of an orchestrator, Kubernetes really has become the de facto standard. There are other options, but let's assume you're going to go that route. If you go that route, there are a handful of things to consider. You could build it yourself, kind of do a DIY Kubernetes cluster, either using bare metal or VMs, and that gives you ultimate control over every individual component. But of course, that comes with the cost of the human power involved to manage it and monitor and maintain that ongoing. So keep that in mind as you're making that decision. Distributed clouds is another really interesting one. Things like Google Anthos or AWS Outpost, they seem really easy at face value because they're offered as a managed service, and they provide a lot of the same interface that public clouds provide. And you may be deploying that elsewhere, so that gives you somewhat of a seamless interaction between on-premises and cloud. But the thing that they don't necessarily call out is that leaves you with managing things like installing, upgrading, securing that base OS, planning the design and implementation of the underlying networking, deploying the storage solution that provides both the fault tolerance that you need for the application as well as the performance to run the workload. Those are all things that someone within your organization is going to have to take care of. And so just make sure you're going to that eyes wide open. The last group I would say here is the container management software, which kind of comes in a couple different flavors. You'll see some that are more ops focused, that are kind of vendor neutral when it comes to DevOps tool chains and application infrastructure software. And then there are others that are more developer focused that will just include those DevOps tool chains, a little more opinionated view as to what software to be used in that stack. But no matter which of these you choose, I think it's important to remember that has to run on some form of actual hardware. If you're going to run this on premises, it's not the cloud. There is something underneath that, underlying that you're going to have to manage, likely alongside those legacy applications. And when I say you there, I really mean someone within the organization. It's likely not going to be the DevOps team, or it's likely not going to be the developers themselves. In fact, when I talk to developers, really, when they're working on new applications, they want to make certain assumptions around the resiliency of the platform on which they're deploying, especially when it comes to persistent volumes where there's some requirement for something beyond stateless. This is where you want to be able to work with the infrastructure teams to make sure that it is designed in such a way that provides the resilience that you require for the application that you're running. And so that's kind of an open question you're going to want to make sure is answered before you go into whatever decision you make for that infrastructure on premises. Ultimately, when the DevOps team is setting up their CI/CD pipeline for deploying out at the edge of the network, that's a huge major point to consider. And it's not just how easy is it to deploy, but it's also the kind of what you need to do to minimize the overhead of managing that infrastructure at scale. Because, it's not, if it's a centralized data center and you have just a single place, that's one thing. But when you're deploying at scale across hundreds of thousands of sites, you have to really make decisions that minimize the overhead of the care and feeding that system is going to require. Another thing to keep in mind is while I show on screen these pretty little graphics of servers and networking and storage, I can assure you the edge is anything but that. If you're looking at cloud computing or tier one data centers, you think of them as physically secure. They're well ventilated. They've got controlled HVAC. They've got redundancy and power with backup generators. Likely have IT personnel right there on site, ready to install or replace or just physically manage that infrastructure. And you think about the edge computing environment, it has none of that. There's nobody on site that has expertise in any of this, nor do you want to staff that. That's expensive. They could be going in next to some, I've talked to customers that are deploying these next to massive machines that are generating a ton of heat in a foundry. Talked with customers that they're putting them, and this is somewhat of a stretch, but putting them over the fryer in a quick serve restaurant, a local fast food restaurant, or maybe just a small tower form factor that's sitting next to a point of sales terminal in a gas station or a retail outlet. Again, nobody on site has the technical expertise to manage that. There's no keyboard, video, or mouse anywhere nearby. So what we often see is that companies will engage in really expensive third-party contracts to be what I call the feet on the street, somebody that you can call in the event of an emergency or in the event of just initial deployment to make sure that there's somebody that can provide that expertise, and that comes at a cost. So our view at Scale Computing is that edge requires simplicity. You need automation that can kind of keep systems up and running. They need to be autonomous. You need to expect failure and absorb those types of events, drive failures, node failures, what have you, to where you can abstract all the complexity of the infrastructure from the infrastructure team that has to manage it, but more importantly, the development and DevOps team that have to have entire ecosystems on top of that. Again, going back to the edge computing sites have no IT staff. Ease of use is of utmost importance. And again, it's not just the ease of use of ongoing maintenance. It's you need zero-touch provisioning to be able to deploy these things without sending people on site. And they need to be done centrally and kind of managed remotely with ease. So probably not surprising to say, that's what we're providing in what we call HC3 Edge. So that whole kind of all of those core tenets and beliefs that we have as a company have been built into this product to provide simplicity, availability, scalability, affordability, and centralized control. And I could probably spend time on each of these if there are questions about them. I'll quickly go to our next slide. This is normally when I would say, hey, let me show you the system. Ease of use is easily said, but it really isn't seen until you're actually using a product and interacting with the data of your own sites, of your own infrastructure to really recognize just how simple the system is to get up and operational. I could talk through, how easy it is to deploy a new site by just entering the IP address and the other relevant information into the centralized portal and then turning on these nodes at the edge of the network and have them reach out and automatically orchestrated kind of the deployment of not just the infrastructure itself, but the applications that are running on top of that through APIs and other sort of orchestration tools on top of that. Again, though, it's easily said, it's way better seen, and I would invite you all to join us on one of our weekly demos where we can go through this in more detail with each of you, or just check out some of the videos online where we get into some of the details around the deployment and ongoing management of these. One of the things that is probably worth also pointing out is when you're talking about infrastructure, not every site is created equal. Not every customer deployment is created equal. Not every application is created equal, which means that you have to be able to mix and match node types. While you want to have a homogeneous way to interact with the infrastructure, you don't necessarily want homogeneous hardware and attributes at every individual site. And so flexibility becomes key in mixing and matching node types and having various infrastructure footprints out of each of these sites becomes important. Another thing that I want to spend a little time on is, when I'm talking about simplicity, again, this is one of those things that's easy to say, but it's really hard to understand just how easy something is. And I'm going to spend a little time around autonomous infrastructure. Our chief product officer likes to beat me up on this probably on a weekly basis, where he tells me the best way to manage 10,000 sites is if they manage themselves. And what he means by that is that there has to be autonomy, there has to be intelligence built into the infrastructure itself if it's going to operate at scale across thousands and thousands of sites. So you've probably heard of what's called an OODA loop, where you observe, orient, decide, and act. And what we have built into HC3 is what we call an UMA loop. So we're observing, orienting, modeling, and acting. And that modeling really is key. It's through hard-won time in the field, understanding failure scenarios and coding solutions to those failures, and then testing them again in those kind of battle testing situations out in the field. We've learned a ton in the last decade or so of implementing this. And what you're looking at on screen is actually a fairly complex environment that is managed and kind of bubbles up just what is important. So at the very bottom layer, you have collectors, and these are things that are sitting on every node in every system that we have ever sold that are looking at just thousands and thousands of pieces of information. And then we orient ourselves. We decide, can we rely on this data through check values? And then and only then do those combine into setting conditions on the cluster. So if it's something like a temporary network issue, where there's a blip in the system, we're not necessarily going to set off a condition that says, hey, this is something you have to deal with. You can almost think of it, if you've heard the movement around AI ops, you can think of it in that manner, in that we're trying to intelligently decide what has to be done, and then we're using those conditions to feed two different things. One is the alerts that are coming to you as the person who might be managing, monitoring all these individual sites, but the second piece is these state machines. So cluster environments are really complex, and you have to understand how to navigate through these in such a way that it works in a clustered environment. So these state machines that we have built into the product are consuming these conditions, and they know what their current state is, they know what their desired state is, and they're able to safely navigate from their current state to that desired state. And only in a situation where it requires interaction with the team that's managing the infrastructure, then and only then, really, when you're getting alerts saying, hey, something has to happen here. Otherwise, the system itself will autonomously take care of itself. That's how we're able to tolerate failures, both at the node, the hardware level, as well as the software level. And also interesting as part of this is, I've been talking a lot about Edge today. We're kind of eating our own dog food here. We use one of the first principles of edge computing in this offering, in that we're not just pumping all this log and telemetry data back to the cloud and trying to sort it all out there. We're doing the heavy lifting of, on-premises, the system's intelligently watching these logs and telemetry locally, and then only sending the useful information back to the centralized piece, which is what we call nucleus. So with that being said, I will say that all of the intelligence we built in the system, all the simplicity, really adds up into thousands of reviews out there from customers across a whole lot of segments, healthcare, manufacturing, education, state and local government, you name it, that kind of seen all the industries, and all of them have very common use cases around the needs for the infrastructure, which is why we've, solved a really key pain point for our customers. And I think that shows in the reviews that we've had out there. So Gartner Peer Insights, Trust Radius, Tech Validate, Spiceworks, you name it. We invite you to go out there and read those reviews, and you'll see some common themes. One of the things that I often hear is the set it and forget it mentality, where people just put this infrastructure in place and they no longer have to worry about it anymore. The other thing you'll see is this thread through our support and services team, and just how fantastic our team that's based out of Indianapolis, Indiana, just how wonderful that team is in supplementing the actual product itself in such a way that it's a true partnership with our customers. And I think you can also talk to our customers directly about those, and really trusted by names that and a lot of names that you haven't seen before, I would say as well, in the last decade or more of having deployed all these. So with that, let me open it up to some of the questions that we've received.
Absolutely, yeah. Great presentation, Craig. I'm just going to bring up this poll question for everyone out there in the audience that we can leave up while we do some Q&A. What additional info would you like about scale computing? And I encourage everyone to respond to that. Lots of good questions coming in. Don't forget about our best question prize we're running as well. If you have a question on your mind, maybe that'll help shake it loose. Craig, Jeff is asking, with scale, can you have more than a 3-node cluster?
That's a great question. Yeah, I think a lot of images that we had in there showed the 3-node cluster, because that's what provides the high availability. That's what provides rolling upgrades and a whole lot of other benefits that you get with kind of a multi-node system like there. But yeah, you can do, we have some customers that will do, maybe at some sites they'll have 3 nodes or 4 nodes or 5 nodes or what have you. Other clusters will have a single node. and making use of things like replication, disaster recovery to replicate their workloads from one site to another or one cluster to another, and doing kind of a manual failover if that's required for their application. Great question.
Nice, yeah. And then another question here, they're asking about migration. If they have an existing compute and storage infrastructure, they're interested in moving to scale computing. What's the process and how easy is that?
Another great question. Yeah, it depends on what applications you're running and kind of what the downtime or tolerance is for those applications. We've got several different tools in place. Probably the most predominant one is one we call HC3 Move, which for most Windows and Linux servers you can install, and it does kind of a byte-by-byte replication onto HC3 and then does the failover and kind of minimizes the impact downtime between those two systems. Most of the customers I would say that we talk to are coming from a VMware environment. There are a handful that are still actually coming from physical environments, but that tool will work across both. And then we have some built-in kind of free functionality that allows you to migrate workloads if downtime isn't an issue. And I would say that, while say 20% of the applications that are coming onto us have really, really high uptime and kind of are critical in nature, and you want to make sure that planned downtime that you have from migrating from one virtualization product like VMware onto HC3, the other 80% fall into that category of, when the time's right, we'll get that migrated over. And for that use case, that's where some of the free built-in tools work really well. But also, we've seen people that will take their current backup product and just convert it to kind of a bare metal restore on HC3 as well. So a lot of different options.
Excellent. And then, we're talking about application modernization here. What about an API? Does Scale have an API?
It does. I probably should have covered that earlier. Yeah, when you're talking about, deploying thousands and thousands of these things out in the field, you can't expect somebody to manually have to go in and manage these and click around and creating new workloads and that sort of thing. It has to be programmatic. So we have built a pretty robust API that's well documented. The documentation itself is within the Scale user interface, but there's also a community of users out in the community.scalecomputing.com site, as well as GitHub, just some Python and other examples out there of how people are using the REST API.
Excellent. All right. Well, I'm afraid that's all the time we have in our live Q&A session, Craig, but there's a lot more technical questions for you there in the queue. Perhaps you can get back to some of those folks. Thank you so much for your presentation. It's always good to have you on. Thanks a lot, Craig.
Thanks, David. Take care.